Hi, I'm Jess from Team Twisted. Our original theme is creative learning, and we have since specified our domain to be teaching colour theory as an academic overtone to promote active collaboration and problem-solving skills for Grade 1 school students. My individual direction focuses on creating an open-ended interaction experience that allows creative freedom. The problem space we identified was a mismatch between the potential for creativity observed in young children and the educational activities to encourage and develop this creativity. Creativity peaks in students of the approximate Grade 1 age, and the Australian education system is currently failing to address this, with a severe decline in the facilitation of creativity observed over the last 25 years. Twisted sets out to address this issue through providing students with an open-ended experience aimed at encouraging and fostering creativity, and consequently enhancing students' collaboration and problem-solving skills through teaching colour theory. The decision to focus on colour theory as the academic overtone to the concept stems from user research, where target users noted art as a favourite subject, and the many benefits to learning about colour theory, such as increased cognitive load and emotional intelligence. Twisted consists of a touchscreen wall and connected interactive mat, intended to be situated in Grade 1 classrooms. Students are able to use Twisted in the allocated art lessons to draw images and colour them in using the mat, which consists of colour pads each representing warm and cool tones of the three primary colours, along with black and white. The intended interaction sequence has been designed to best achieve the intended experience outcomes and draw upon users' innate skills. When Twisted is introduced to a classroom, the teacher is expected to give students a short explanation and demonstration of use to assist the young target audience in understanding the concept. Students will then be encouraged to use the concept in pairs or groups to target collaboration and in turn enhance users' communication, empathy, confidence, and problem solving. The unrestricted manner of interaction was included in response to feedback that the initial form of Twisted did not provide open-ended interaction. This was also done to provide creative freedom for students and a learning environment where there are no right or wrong answers. Both a visual representation prototype and a functional prototype have been created to demonstrate a comprehensive view of the overall intended form, functionality, and interaction. A visual representation of the intended form was created in order to best demonstrate interaction that was limited in the functional prototype. The main drawback with the functional prototype is that it's currently on a scale much smaller than the intended concept due to resource limitations. The visual prototype has been created to the intended scale and has been made out of a twister mat, with colour printouts attached as the colour pads. In this prototype, a plain wall represents the interactive wall, with editing creating visual representations of the user's drawings. In the intended interaction, users will firstly use their finger to draw an image on the interactive wall. From here, users can select the segment they want to colour first and move to the mat to begin colouring. Users must stand on the colour pad they want the selected segment to be filled with. For example, if the user stands on the warm blue pad, the segment will immediately become warm blue. If the user remains standing on the warm blue and then applies another foot to cool red, the segment will now display the combination of these two colours, purple. Twisted also aims to foster collaboration and encourages use by multiple students at the same time, working in synergy to create a desired colour. For example, if one student stands on warm red and wants to create orange, but for example cannot reach cool yellow, another student may step on the yellow pad to assist. It is intended that after this process firstly occurs, students add their own drawings or extensions of their peers' drawings to the wall. This promotes reflecting on students' own work as well as their peers and allows students to create a shared visual representation of their imaginations and creativity. The functional prototype currently depicts a very accurate representation of the intended functionality, with only one element currently being simulated. Interaction with the functional prototype is similar to the intended interaction, except on a smaller scale, where users use their fingers instead of limbs to select colours. Users firstly draw their image on the touchscreen, select the desired image segment, and then move to the A4 version of the mat, pressing on the sensors to select and mix colours. When two sensors are touched, the combination of the two corresponding colours will be displayed on the screen. The prototype consists of a small-scale version of the interactive mat and a computer screen as the interactive wall. A Microsoft Surface was also able to be used for some demonstration to better depict the intended interaction due to the touchscreen. The functional mat was created using colored paper for each color pad and capacitive touch sensors to sense when a color was pressed. This was decided as the most sensible method of sensing touch for this prototype due to the use of fingers. However, if a full-scale prototype is eventually produced, pressure sensors will be used instead. Each capacitive touch sensor was connected to an Arduino pin that was then used to read which color was selected. The capacitive touch sensors indicated that a color had been touched when the corresponding color sensor displayed a reading higher than 100. Each time a color was selected, a representative number was sent to the serial to be read by Unity, and then the segment fill color was changed to the color of the pad that was pressed. If multiple colors were selected, the combination was assigned a separate number and displayed on the screen. In future, a more efficient way of mixing the colors will be explored to enable mixing of numerous colors. A free draw asset is currently being used to enable drawing on the screen. Ideally, users would be able to draw their image and then select a specific segment to color in. However, the free draw asset inhibits this process, and this element has been simulated. A pre-existing circle has been added to the Unity scene, which is the current segment to which color changes are being applied. Future discovery will be conducted to find a solution so that this element does not have to be simulated. Regardless, the current prototype effectively demonstrates the intended interaction and experience, and future prototypes will aim to better represent the visual form and allow intended use.